Moisture, correct? Okay.
So it also alters the amount of aerosols present in the air.
So in refrigeration, it
Is
takes
that the
heat
purpose?
and to give store heat.
Wait. Is that the purpose? Absorbs the aerosols and all. Is that the purpose? For that, there are many other techniques also available. What is the meaning of air conditioner? Cooler is
Sir,
cooling. Okay, fine.
in
Simple
air
word.
conditioner, we can change the temperature of air according to our needs. Like we can make it cool and
Please
hot.
repeat.
We can change the temperature of air
In what?
with our like in air conditioner, sir.
तो वो तो कूलर से भी हो सकता है.
ऐसे कूलर से खाली ठंडा कर सकते हैं ना.
तो
कंडीशनर
टेम्परेचर
से
से और
गर्म
क्या
ठंडा
होगा?
दोनों.
ठंडा और गर्म.
ठंडा. हाँ सर, तो गर्म भी कर सकते हैं सर.
Okay, fine.
Sir,
Good point.
the level of moisture which is actually required to be present in room or in the air which you are saying, it is somewhat somewhat related to the comfort level of the human who is staying inside.
Comfort level. Okay, very good.
Sir, in air conditioner, we are using a single refrigeration in a continuous cycle, whereas in air cooler we have to continuously supply a dry air.
No, because there also you have the input as whatever outside air and your output as per the requirement. In air conditioner also it is, let's say, dry air or whatever outside, and the output as per the requirement. There is a difference in the output itself for both the things. What is the
So
difference?
in AC, the temperature can be changed, but in refrigerator, temperature is fixed.
Please repeat.
In refrigerator, the temperature, there is no change in temperature. The temperature is maintained throughout in refrigerator.
I'm not asking anything for refrigerator. I'm asking the difference of air cooler and air conditioner. Refrigerator कहाँ से आया? There is one dabba, air cooler. There is another box unit, air conditioner.
Our cooler is simple in design as compared to AC.
तो क्यों लेने का AC? कूलर ही लगा दो. Will the purpose get served?
कूलर के लिए कंपलसरी वी नीड ड्राई एयर बिकॉज वो मॉइस्चर से काम करेगा, मतलब अंदर मॉइस्चर इंपार्ट करेगा, देन ओनली इट विल कूल. बट
let me reframe the question in some other sense so that it would be, I think, better for you. Under which conditions you will employ air cooler and under which conditions you will employ air conditioner?
So air conditioner mostly in a closed environment like indoors, and air cooler can be employed in outdoors as well.
Sir, air conditioner dry area like Rajasthan or something. Air cooler.
Like we can't use air coolers in Mumbai, sir, because of so much humidity, sir.
Why?
Because of humid conditions, sir.
Humid
like
conditions. Okay.
Yes,
so that means something related to humidity.
Yes, sir.
Okay. And someone said about temperature. So temperature, heating and cooling, both possible.
Yep, sir.
In air conditioning. Air cooler is simple cooling. It cannot heat.
Yes.
In air conditioner, there is a heating coil, there is a cooling coil. So that is on temperature front. And on the humidity front, you can add the moisture, you can remove the moisture. There is a humidification system, there is a dehumidification system, both. So accordingly, you can play with both the fundamental properties, temperature plus moisture. I already told dry air, a separate entity, water vapor, separate entity. A homogeneous binary mixture is our general air. Dry air, that means without any moisture. And then water vapor. That is basically moisture content. So that is what is our atmosphere is. If you move away from the seashore, this humidity changes. So I have to set or I have to design a unit which will control not only the temperature, but even the moisture content also, or humidity also. So air coolers are generally preferred in the dry places where only cooling is required. And air conditioners are the universal one. Have you ever come across the situation that, let's say, Blue Star is making the advertisement that these are the ACs for Mumbai, these are the ACs for Rajasthan, these are the ACs for Himachal Pradesh, something like that. They are universal. What is the meaning of universal? That means they are capable of maintaining air conditioner. Conditioner means what? It conditions the air. So it maintains the condition of the air as required by all the positive and negative processes. Positive and negative in the sense heating and cooling, humidification and dehumidification, both. Air cooler has only one process, rather, I should say two processes. One is cooling, and the other sometimes dehumidification. It never humidifies. Oh, sorry, ulta. It humidifies, never dehumidification process. एयर कूलर किसी ने खोल के देखा है कभी? It's a huge belt dipped in water, and there is just a blower behind it, and it just
Yes.
adds the moisture. So it is just a humidification process. There is no dehumidification part. It can never take out the moisture. It can just add the moisture. And what we observe is the cooling effect because of the addition of moisture. Naturally, पानी में ठंडा लगता है ना. So if you add the moisture in the water, air, naturally you feel cool. So there is absolutely no control on this particular process. Whatever is the speed of the fan and speed of the motor, accordingly fixed amount of moisture will be added. You will feel one particular finite stable temperature. You cannot change it. This is what is air cooler. Whereas in air conditioner, you have liberty to do anything you want. You can add the moisture, you can remove the moisture, you can heat the air, you can cool the air. I mean to say increase the temperature, reduce the temperature. How we achieve that, I will tell you when we start with that particular chapter. But this is the basic difference between the air cooler and the air conditioner. And that is why, as someone said, air cooler is very, very cheap. Because उसमें कुछ control है ही नहीं. Air conditioner is naturally expensive because it has so many controls possible. Fine. Okay, so refrigeration is absorbing the heat. Then, as someone said, it takes place at a constant temperature. Then, air conditioner, as the name says, we condition the air. And what is the meaning of conditioning there? That means temperature and moisture. Fine, very good. And then we discussed about air cooler and air conditioner difference. Okay. So now here, when we go for the refrigeration, naturally it's a closed cycle. So we will be discussing about few cycles starting from Carnot up to vapor compression cycle, vapor absorption cycle, a few more advanced cycles, even Brayton cycle as you use it for the gas turbine. Gas turbine ho gaya na in your syllabus? Maybe
Yes,
in
sir.
IC engines, SEM 6.
Yes, sir. Yes, sir.
Okay. So if you reverse it, you will get the air refrigeration cycle. What is wrong in that? If Carnot can be reversed, why not Brayton can be reversed? Okay. So that way, I can use the air refrigeration, which is very, very common in aircraft applications. So another difference is refrigeration always works on cycle. Air conditioning is always a process. It's not a cycle. It's just a process. Cooling with dehumidification, cooling with humidification, heating with dehumidification. All these are processes. There is no cycle. Start point is fixed, atmospheric, whatever it is, temperature and humidity. Your end point is fixed. That is what you set using the control panel on the air conditioning front panel. Correct? So it is just a process starting from state 1 to state 2. Whereas refrigeration, you have to complete a cycle. It's not just a process. Fine. That is another difference. Anything else you want to add? Or maybe at the end of the semester when I complete my semester. Let me try to find out new syllabus. But I don't think fourth year. Anyone has been fourth year syllabus? Your revised one? What I have is the old version. CR or anyone?
So which one is the revised one? 2019 one?
18. All those are having the course code as R4ME. All earlier were only ME. Earlier this course was having code of 3011. Now it must be R4ME something.
Yes, sir, we have it.
So just share the screen.
I have it on my phone, sir. I'll email it to you right now.
ईमेल ठीक है कर दो.
Yes, sir, I have sent it to you.
कुठे पाठवलं विजिटे आहे ना.
हो सर.
नो जीमेल. Not yet received. Yes, okay. Fine. So this I need to open first. Final year. 1819. Okay, fine. So let me take you to the details of the syllabus. And this is in 8th semester. Now this become 4007T and T. Fine. This is the list of your electives. Entire screen. Share. Can you see the screen?
Yes, sir.
Okay, so now here, this is your course code. The prerequisites are thermodynamics and heat transfer. So now I have full freedom to assume that you are clear with thermodynamics, SEM 3, and you are clear with heat transfer, SEM 5. Okay, those are the prerequisites which you have done successfully during your second year and third year. So based on that, all the analysis of all the processes or the cycles, whatever they're incorporated in this particular syllabus will be realized. Now the course outcome. He analyzed the basic cycles of air refrigeration. Fine. This is altogether a separate part because Once I say air refrigeration, that means you can apply the ideal gas law. So this is the simplest one. Then second, evaluate the performance of the vapor compression refrigeration cycle. So here, this is the cycle which is heart of our domestic refrigerator. Okay, everyone who is having a domestic refrigerator, it works on vapor compression refrigeration cycle. So I will tell you, I will teach you how this works, what are the pros, cons, limitations, everything. Okay, then third part, analyze the vapor absorption and the other advanced refrigeration cycles. Now, vapor absorption is what I can say substitute for the vapor compression, because for compression process naturally it requires electrical energy. Vapor absorption, I can get rid of this compressor work. There is no compression, it's a simple absorption process. So I basically can claim to increase the COP. How do we define COP? Thermodynamics, refrigeration effect divided by work done. Work done means compressor work. So if I remove this compressor part itself, then my COP theoretically should be infinity. So that is what I try to do in vapor absorption system. There is a little work, of course, but the prime objective is to increase the COP by getting rid of the compression. So this is why instead of vapor compression, there is a vapor absorption. Okay, I will tell you how this works. Then fourth is analyze various psychometric processes. Now here, first of all, what is psychometry and then what are psychometric processes? So psychometry is the study of this moist air, as what we just discussed. Dry air plus water vapor, binary mixture. That is what we call it as a wet air. Dry air plus moisture, so we call it as wet air or moist air. And science of study of the moist air is called as psychometric. Read the spelling carefully. It is psychometric. Don't say psychometric. Many people say it as psychometric. Nothing psycho in that. Okay, so it's a psychometry and accordingly psychometric processes. And their application. Application is what? AC, air conditioning unit. And the fifth part is important from environmental point of view. So provide the remedial actions for the harmful effects of the refrigerants on the environment. This is now very, 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 very important. How many of you are aware which refrigerant is there in the domestic refrigerator unit at your home? Chalo, bolo.
R143
143 or 134?
134.
134 है
143 नहीं होता है. 134. Okay. Any other? 404, 416. Anybody using it? Nobody. Who had bought a domestic refrigerator in last year? During last year, I should say. उसमें या तो 404 होगा या 414 होगा, 416 होगा. 134A is also little bit old now, I can see. Anybody having the unit of R11, R12, R22? Okay. Same information you should have about the air conditioning unit at your home. Because the basic heart is a refrigeration cycle. Always remember, I asked the very first question, what is refrigeration? What is air conditioning? Are they linked? You have answered 2 out of 3. What is refrigeration? You told. What is air conditioning? You told. How they are linked? Or they are not at all linked? Then why we should study together? Refrigeration बोल दिया, air conditioning बोल दिया. Why we are studying them together?
sir same cycle
Same cycle? No. I just told refrigeration is a cycle. Air conditioning is a process.
The purpose of both is basically the same, right?
Please elaborate.
So
What do you
both
mean
are
by that?
used to cool a particular area, lower the temperature compared to the surrounding, right? Basically.
No, be specific. You are on the right track, but be specific. Refrigeration is directly applicable. That means you are extracting the heat from the substance itself. Air conditioning is applicable, as the name says, to the air only.
Yes.
So always remember that when you change the properties of the air, in bracket psychrometry, as just I said, air conditioning is psychrometry. So when you want to achieve any psychrometric process, cooling with humidification, cooling with dehumidification, heating with humidification, blah, 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 whatever it is. Okay, then to change the air state from 1 to 2, whatever process you execute under psychrometry are to be necessarily and compulsorily supported by the refrigeration cycle. Always remember this, because you are changing the properties of the air. But who will do that? Refrigerant will do that. So in a cyclic process, you make the refrigerant to flow, and the effect will be observed in terms of the change in the air properties. This is how they are linked. So if you open the air conditioning unit at your home, there is a refrigeration circuit inside. Always, always. There is no single exception. Okay. So a cyclic flow of the refrigerant will help to generate the situation with the help of which you will alter the air properties. If I want to change the air properties, who will do that? There has to be some working substance. What is that working substance? That is the refrigeration cycle. Are you getting it?
Yes.
So this is how both of them are linked. So initially we will be studying refrigeration and then use the same refrigeration cycles or the principles to achieve the air conditioning processes. Air conditioning is not a cycle, I told you. But to achieve that process, the background is the refrigeration cycle. You cannot execute any air conditioning process without employing refrigeration. Always remember this. Okay, so this fifth CO is related to that which refrigerant I should use from environment point of view. Because in earlier days, majority of these refrigerants were the CFCs, chlorofluorocarbons, and very, very harmful to the environment. And then the global warming and all those issues came into existence. So that is why this particular bit is very important, which refrigerant you should use. So let's say, for example, you want to buy a refrigerator for your home, or even air conditioning unit for your home, and you go to the market, then don't just look at the cost only. Of course, we have to look at the cost, but you have to look at the refrigerant only also. Reason being, there are complete bans on certain refrigerants. और दुकानदार जो होते हैं बहुत शाणे होते हैं, वो क्या करते हैं, पुराने रेफ्रिजरेंट वाले सस्ते में बेच देते हैं एयर कंडीशनिंग यूनिट, एंड देन वी कम बैक होम dancing that I saved some 50%. My air conditioning unit is, let's say, 55,000 and your unit is 35,000 rupees. That doesn't mean that you are a clever person. Rather, you are a fool because you bought a old refrigerant cycle, a unit, which is now obsolete. There is a ban. So please take care when you go to the market for buying a refrigerator, domestic refrigerator, or even an air conditioning unit, please ask the seller about the refrigerant. And if it falls under the category of acceptable one, then and then only buy that unit. Okay, the seller will try to make you fool. अरे वो 55,000 का क्यों लेते हो, ये 35,000 का ले लो. The immediate ring that should, or the signal that should ring in your mind, is to cross check the refrigerant. Why he is giving something in 35,000 instead of 55,000? That is because of the old refrigerant, which is now completely banned. So very first task I'm giving you in this today's lecture is to cross check the refrigerants at your domestic refrigerator unit and the air conditioning unit, and check whether they are acceptable or not. 2020 was the year when all of them got phased out. And I think for India and certain other countries, they had given some extension up to 2025. Uske baad, if you use this, then there is a heavy penalty that got extended because of the pandemic only, nothing else, no other reason. So if you continue to use that refrigerator or the air conditioning unit further, then you will have to pay very heavy penalty to the government. So please cross check about the refrigerant. Okay, so this is more towards the course outcome. Now the content. If you observe the first unit, basic refrigeration system, where, as I discussed, we will be discussing a little bit about the Bell-Coleman cycle or the reverse Brayton cycle, reverse Joule cycle. All names are like cycle is same. A little bit about basic theory of COP. That is just a revision of the second law of thermodynamics, with the help of which you define refrigerator and heat pump. Okay, so air standard refrigeration cycles and how they are used for aircraft applications. Now, air refrigeration cycles are restricted only for aircraft application. Nowhere else in the world they are getting used. Why? I will tell you at that time. Then the immediate next unit is the vapor compression refrigeration cycle, which, as I had said, is the heart of your domestic refrigerator system. So we will analyze this cycle, vapor compression cycle, in full depth. Then we will further move to advanced refrigeration system, where I will be focusing more towards this first part. This is the major part, which is vapor absorption refrigeration. And this bit, electrolux, thermoelectric, waste heat, cogeneration, magnetic triple fluid, and steam jet. These are like short note types of questions. So I will give it to you people for, what do you call that? Some assignment kind of thing. So prepare a short article, short note of 3 or maximum 4 pages, including the schematics and then working principle and then cycle and advantages and limitations. Bas. And then submit it to me. I will go through it. And once I approve it, then you can exchange with the rest of the class. It's just a very simple theoretical way. No numerical will be set on this. I'm not going to ask for a performance evaluation of thermoelectric refrigeration. It's just like a simple short note type of question. So we can do it in our leisure time. Where is that bit for the refrigerants? Chiller packages I had added over here. Somewhere here I had mentioned it. I don't know at the time of compilation whether it got removed or what. Anyways, then we will enter. This ends for our refrigeration part. Then we enter into air conditioning. So this is psychometry and air conditioning processes. So here we basically deal with a definition of air conditioning or psychometry. Then what are the properties we should focus? How do we calculate them? What are the methods? What are the mathematical formulae? And then finally, how those charts are prepared. Yes, that made me remember. You have to deal with hundreds and thousands of charts in this particular course. because every refrigerant is having its different chart. And then finally, air conditioning means psychrometry chart. So there are hundreds of charts. I will share with you what is the standard reference that need to be considered. That also I will share with you. So all your assignments or ESC paper, MST paper, whatever it is, will be having those standard charts. Okay. So as and how that time comes, I will share with you with all the detailed information. So how the psychrometric charts are prepared, and then these are the different processes. So mixing, then heating, cooling, humidification, dehumidification, all such kind of processes, and their corresponding what I can say specific terminologies, ADP and bypass factor and all those things, SHF. All these things will be discussed in that particular chapter. Okay. Oh, sorry. Huh. And then yes, this is the practical application at your home. Summer AC, winter AC, year-round AC, then room air conditioner, split air conditioner. So I will cover up the entire theory part and I will tell you what to do for these small bits, central AC, AHU air handling unit, then package AC and etc. etc. So those are also again very similar way to refrigeration. These are also like the simple short notes. So I will tell you what to do under this as far as your syllabus is concerned. Okay. All the theory part I will be covering. Don't worry about that. Only these short note types of thing where no theory, no mathematical equation, no numerical, nothing is expected. Simple word part theory. That I will tell you how to do that. Fine. Ah, yes, okay. We shifted that refrigerants as the last part here. So here we will be discussing about what are the different refrigerants. The typical nomenclature, we call it as ASHRAE nomenclature, American Society of Heating, Refrigeration, and Air Conditioning Engineers. Our home version, Indian version is ISHRAE, Indian Society. So what we do? Copy paste. Whatever ASHRAE says, we say that ISHRAE says the same thing. Satchidananda Baba. Okay. So we will follow those ASHRAE nomenclature. Then we will deal a little bit about certain chemical part for the properties. And the most important thing is this alternate refrigerants. You must be able enough to know which refrigerant is obsolete now and which one is the substitute for that. You cannot simply take out one refrigerant and fill any other refrigerant. You will not achieve the performance because naturally the thermophysical properties are different. So which refrigerant to be replaced with which other one is a technique. So we will discuss about that. And then certain part over here as the uh, again what I can say theory note, ODP, GWP, and then these two protocols, Montreal Protocol and Kyoto Protocol. They are basically the protocols how to phase out the refrigerants and introduce the new one. Then what are the penalties and what are the deadlines for which countries and etc. etc. It's a pure theoretical one. So I will tell you what to do about that afterwards. The theory part about the ASHRAE nomenclature, alternate refrigerants, all these things that I will teach you properly over here. Okay, so this course will be a blend of certain part, I will say 80 or even 85% as a basic theoretical or conceptual understanding part that of course I will take. And 15% will be like these small bits, short note type of thing. So as the your syllabus structure says that maximum 20% could be given for self-study mode. So I will give you such small bits for self-study mode. All the theory part, all the basic understanding part, that is my responsibility that I will complete. I will teach you. Okay, fine. Any doubt, any suggestion? No suggestion. Fine. Now the books. You can refer to any three of these textbooks. Aurora Domkunwar is one of the finest books available for RAC, and it is very easily available in the market. So those who are staying, and this is like Indian thing, so anywhere, whether you stay in Mumbai, Pune, or any remote area of Maharashtra, you will get this very easily. Second book is Manohar Prasad, IIT Kanpur professor. So this book is not good for numerical practice. Conceptually, the best I can say, even better than Aurora Domkunwar. Manohar Prasad is far better, but the mathematical part means numerical part is not so strong over here. Strong in the sense this is a typical way IIT professors do. Even in IIT also lecture, if any of you were having your friends in IIT, there are only one or two numericals will be taken just to give you the idea. So that is the same way the book is written. So only one or two solved numericals would be there. Everything else you have to do on your own. Whereas Aurora Domkunwar is a typical engineering book. There will be hundreds of solved numericals. So you select as per your choice. CP Arora is also same, IIT Delhi professor. So here also a little bit coverage of numericals, maybe maximum 4 or 5 numericals solved, and hundreds of numericals as unsolved. Fine. Now these books, 3 books, will cover about majority of the portion. Aurora Domkunwar hardly covers about vapor absorption. CP Aurora, I think, doesn't have it at all. Manohar Prasad covers it very nicely. And if you want to go into the depth for vapor absorption, बाकी आपका सब portion निकल जाएगा. Vapor absorption अगर ज़्यादा depth में देखना है, so this is the best book. Trickled. This is the best book for vapor absorption refrigeration. But unfortunately not available as a PDF copy, ebook. There are copies available in VJTI library. Those who are staying in Mumbai can come and get the book issued. But another and major difficulty that this book is available in FPS. It's not available in MKS system. I think this latest edition, third edition, is in MKS. But first and second edition, what VJTI has is FPS editions, not the MKS one. So that is somewhat a major difficulty because every time you have to deal with degree Fahrenheit and pounds of refrigerant and then calorie instead of joules. That may be problem, but that is for solving the numericals. Theoretical background for theory knowledge, this is the best book for vapor absorption. So all in all, even if you take any of the textbook, 85% of your syllabus will get covered, no issue about that. Manohar Prasad will cover 100% syllabus. And as far as numerical practice is concerned, then Aurora Domkunwar. Theoretical aspects, I will say all three are good, no issues. And I have deliberately added all 3 Indian author books so that you can get them very easily. Aurora Domkunwar, I think PDF is also available. I'm not sure, but you can cross check. I think that PDF is available. Manohar Prasad is not available. I think Google Book has the online copy. You cannot download it, something like that. And CP Aurora Simple is not at all available. PDF. But these are so common and standard book that you can get it in any book market, even like local places also. You need not go for metropolitan cities. Everywhere you will get these books. Nashik, Aurangabad, Yavatmal, everywhere. So wherever you are currently staying, it's very easy to get these books, at least one of these. That should not be a problem for you as far as your studies is concerned. Okay. And other than this, we need different charts, as I had said. So please don't buy any book for that. I will be sharing all the charts with you through this GVC, Google Virtual Classroom. If you require, you can just take the print and it's fine with that. Okay, don't go and buy any book for the chart. because there are hundreds of charts and it's of no use as such. Okay, one or two charts are more than enough. You get the idea, you get the concept clear, and then in the exam also I will be telling you that use this particular chart. So that is more than enough. Don't go for printing all 100 charts. Or rather, don't buy such book. Fine. So that is something for the charts or solving the numericals using the charts. Okay, I think that gives the syllabus over. Fine. And then this is the laboratory course. So here, as I had said, course outcome is the same. Evaluate the performance of simple vapor compression system. That is what I told. We will just calculate the COP. Whatever is the input, whatever is the output. Then the second one, optimize the performance. So here we will dealing with the parametric optimization. We will change the parameters and see what is the effect, whether it is predominant or the nominal one. Then the third is the thermoelectric heat pump. Unfortunately, that is not working. And because of the pandemic, we couldn't get it repaired because it is made in England. So no one is ready to come from England and repair it. So forget about that. Then the fourth is, yeah, I replace this. I'm replacing this thermoelectric heat pump by a vapor absorption system. So instead of this thermoelectric heat pump, band hai to band hai. We will not stop. We will go for the vapor absorption refrigeration. So third experiment will be a substitute one. Fourth is psychometric properties. So here you will calculate actually with the given known conditions, you will calculate all the properties, whatever you will be learning in the theory classes, you will be applying over here directly. And fifth is the psychometric processes. So here you will select 2 or 3 processes and you will try to plot it psychometric chart and give me the answer. Okay. So accordingly, the list of experiments set. It is running so fast. Test on water cooler. So this is like calculation of COP will not change anything. Then performance test. This is parametric optimization. Then ये उड़ गया इसकी जगह पे vapor absorption. Then the psychometric properties. That is by using the basic equations and the chart verification. And then performance test. And this 6th part we unfortunately cannot do. Otherwise, I would have taken you outside. Visit to a refrigeration plant. Every year we do it. We go to Nashik. There is a cold storage plant. So I could have taken you over there. We have very good relations now developed with them. But unfortunately, because of this restrictions, no visit is possible. Anybody having any personal contact? Probably then we may get the permission. As I said in the beginning of the syllabus itself, refrigeration air conditioning is not a course which is like a theory one. You have to feel that cold, you have to feel that humidity. Then only there is some fun in that. Otherwise, it's like just a theory part. Anybody from Nashik? From the entire class? Nashik is famous for cold storage plants. Grapes. Anybody from Nashik?
Yes, sir.
Yes, sir. Yes, sir.
Who is he or she? Yes. Who said?
Sir,
Yes.
Sami Omkar.
Rakshas.
राकेश बर साधारणपणे काय त्या ठिकाणाचं नाव नाशिक कडनं पुढे धुळ्याला जायला निघालं की डाव्या हाताला कुठला एरिया आहे तो सांगा बरं म वरनं नाव आहे त्याचं काहीतरी
मालेगाव.
नाही नाही एवढं पुढे नाही रे नाशिक सोडल्या 4 किलोमीटर म्हस काय म्हसवड सारखं काहीतरी नाव आहे बघा त्याचं
मसरूळ मसरूळ
मसरूळ येस तिथे सह्याद्री ॲग्रो असा हे आहे प्लांट आहे त्यांचा कोल्ड स्टोरेज प्लांट तिथे काही हे आहे का कोणाची काही ओळख बिळख असेल तर काढा मग आपण 2-3 बॅचेस मध्ये जाऊ गर्दी टाळायची असेल तर.
ओळखता नाही सर ही, पण विचारून बघेल मी कोणाला.
आता जानेवारी आहे फक्त, आपल्याकडे एप्रिल पर्यंत वेळ आहे. एप्रिल पर्यंत काही राहत नाही कोरोना बिरोना, सगळं जाईल. तुम्ही सगळं ओपन झालं की जायचं.
सर विचारून बघतो, माझी तशी ओळख नाही पण विचारून बघतो मी.
हा म्हणजे आम्ही दरवर्षी तिकडे नेतो.
अच्छा.
वी यूज टू गेट दिस IV ऑलवेज ओव्हर देअर लास्ट 6-7 years. So we have good relations over there. But of course, it is not mandatory to go to that plant. There are hundreds of plants for a nearby area.
Yes.
Nashik is famous for that.
Yes sir.
So
Right.
if you have contact of any other cold storage plant, then we will go over there. What is big deal? सह्याद्रीच पाहिजे असं काही नाही.
अच्छा.
Okay. So
Okay,
those
sir.
who are staying in or around Nashik, having any contact, personal contact, or even political contact, then we can arrange this. Maybe a little bit late in the month of April or something. But I want you to get this experience. How
Okay, sir.
refrigeration
I
air
will try.
conditioning feels like. How it works like that, I will teach you in the class. But how it feels like, that is the experience you should get. Because I know everyone is aware with this thing. Everyone is having the refrigerator at home. Everyone is having the air conditioning unit at home. Correct? But you are not aware with how it works. So that I will tell you. And then you feel it in some huge capacity. Not like a domestic one. Then it will be like more appreciated. Fine. So that's all from my side as far as syllabus, textbook, evaluation, everything is concerned, including possibility of IV. So if you want to know anything, let me know, or otherwise we will stop. You have the next lecture, right? Tomorrow we have lecture, right? Or not? I don't know how they are now scheduled. I have to download that.
Yes, sir, we have tomorrow, 3 o'clock. No,
Fine. So, whatever it is, so tomorrow we will start with the first chapter itself. Today I tried to give you the glimpse. Okay, you want to know anything or should I end the meet?
so we can end the meet.
Okay, fine. Very good. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.